Hello viewers, welcome to another video with Physics Anchor. Today we have a question on the board from JAMB Past question, and this question was actually sent to me by a JAMB student. So you can also send questions to me in the comment section below so that I can actually make video with those questions for you and other students to learn from. So let's get to work with the question we have on the board. An electric heater rated 220 volts, 1000 watts is immersed into a bucket full of water. Calculate the mass of water if the temperature changes from 30 degrees to 100 degrees Celsius and the current flows for 300 seconds. So in our culture, it's always good for us to write the parameters given so that we know what we have and what we are looking for. So let's do it that way. So here we can see that they have given us the voltage, which is 220 volts, and it's actually in its SI unit, so we can make use of it like this if we actually need it. So we don't need to convert it, it's in the SI unit. Also, we have power, which is 1000 watts. We also have we also have the temperature changes. We have theta 2 equals to, let's start with theta 1, that's temperature 30 degree, and we have theta 2 equals to 100 degree Celsius. So we can easily find the change in temperature here as theta 2 minus theta 1, which will be 100 minus 30, and that will give us 70 degrees Celsius. Okay, so we already have this. We also have a specific heat capacity of water being given as 4200 joules per kilogram per Kelvin. Okay, so we do not have any conversion to do. Everything given to us are actually in the units, SI unit, that we can make use of. So we do not have any issues with converting here. So they are asking us to calculate what mass. Don't forget that our time was also given to be 300 seconds. Yes, the time is 300 seconds. So it's two currents to flow for 300 seconds. So the unknown that they want us to find is the mass, which is the what? Question mark. Now let's look at the combinations that we have here. Of course, we know that having the temperature changes and having specific capacity, that already tells us that we are going to calculate what? The heat energy. Okay, that's the heat energy. So the heat energy is calculated as a MC, change in temperature. That's M for mass, C for specific heat capacity. Okay, and in this case, specific heat capacity of water, and we have the change in what? Temperature. So that's for H. So we have made use of the change in temperature, the specific capacity, and also the mass is already included there. Now another thing is that let's look at power. Okay, the voltage and the time that they actually what give us here. That can also give us a clue that, well, we know that power is equals to energy over time. Okay, and energy equals to what? Power times what? Time. So this is another definition. So this is heat energy. Okay, and also this is also a form of what? Energy. So what we need to recall here is that in conservation law of energy, we learn that energy cannot be created nor destroyed, but can be changed from one form to another. In other words, so the heat energy here, okay, can be compared with what? The energy that we also what? Have here. So this is heat energy, this is electric what? Energy. Okay, because the thing we have here was actually said that what? The current flows for 300 seconds, and the power that we have here is actually of the electric what? Source. So this is electric energy and this is heat energy. So the electric energy, okay, is the one that brought about what? The temperature changes here. Okay, if you read the question very well. So it's just like you put what, an electric heater. So the heater is making use of the what, electric source, that's electric energy, and the water, okay, the heater actually raise the temperature of the water from 30 degrees Celsius to 100 degrees Celsius. So in other words, the energy of the electric energy from the heater has been converted to what, heat energy, in raising the temperature of water from 30 degrees Celsius to 100 degrees Celsius. So energy has not been destroyed. We have not created new energy. We have just successfully converted what, energy from what, electric form to heat form. So we can say this energy is equals to this energy, and exactly that's what we are going to do. So we have H is equals to what? Let's just call this electric energy. So that will be MC change in temperature equals to what? Power times what? Time. Okay, and the mass will now be equals to power times time all over C, which is specific heat capacity of water, times or change in what? Temperature. So let's start putting our value now. So we have 1000 times the time, which is what, 300, all over. So the specific heat capacity of water that we are being given, that's 4200. So that's 4200, and the temperature change actually gave us 70. So that is what, 70. All right, so let's see how we can actually cut down some things here. So this is 0. Okay, cancel 0 here, 0 cancel what, 0 here, and this also cancel what, 0 here. So we can also say that what, 3 here 1, 3 here will be 1 4, that will be 14. Okay, and let's begin to look at the way they left the options so that we know what we actually what doing. So we can also say 2 in 100, that's 50, 2 here, that's 7. So it will be 50 over 7 times 7 that remain here, that's 49. Okay, so if we are to divide 50 by 49, that will be 1, okay, point, all right, 0, and in 100 we are going to get, that's 98, that is 2. So everything that they left here, they actually left them in 2 decimal places. So I can stop here. So that would be kilogram. So that's what we have. So let's check the options. So not A, not B, so C. If you have your own calculator, of course you should have a simple calculator during your exam that can do something like this. So just quickly get your answer. Because I'm working without calculator, that's why getting this, dividing this was actually what, as slow as that. You have to be very fast and make use of all the necessary resources that you may have during your exam. So that's what we have. Now you may be wondering that there is a voltage being given here that we did not use. That's to tell you that sometimes they may give you overwhelming items, overwhelming, parameters that even some of them you might not use. It rarely happen, actually. It rarely happen that they will give you some information that you may not need, but that does not mean that it doesn't happen. So in this case, you can see it does happen that sometimes you have information that you don't really need to make use of. So in this case, we did not use the voltage. They are just trying to tell us that what, the heater is using a single phase, electric source. So it's using a single phase. That's why they actually put these 220 volts there. It's just to tell you that what, the heater that they are using here is actually using a single phase, which is the red and black. That's live and neutral. So that's what this actually is actually doing here. It's not that you need it in the calculation, but it's just that they are just indicating that this is a single phase what, electric what, heater, which is what, 220 what, volts. So the power is actually the actual thing that we need in this calculation. I hope you do understand the solution, and I encourage you to please share out these videos so that other students can also benefit from it. Hit the like button, subscribe if you have not done so, and please turn on the notification button so that anytime I drop a new video, you can get informed. I wish you all the very best in your exam. Bye for now.